In this example, I have been asked to find the domain, x-intercepts, y-intercepts, and all asymptotes, and then graph the function. I will use my 8-step approach to do this. The first step is to find my domain. To find the domain, you set the denominator equal to 0. So in this case, x squared minus 81 equals 0. Well, to be able to solve this, I can either solve by taking roots or I can factor. I think factoring would be easiest. So we'd have x plus 9 and x minus 9. Set both of those factors equal to 0, and we would get x is negative 9, and then out of this one we would get x is positive 9. So basically here what we're saying is that domain can be every value except these two values. What I've said as far as trying to come up with interval notation is to kind of draw a picture of what we have here. We can't have the value negative 9, we can't have the value 9. So the domain would be negative infinity to negative 9 union negative 9 to 9 union 9 to infinity. The second step is to find the x-intercepts. Well, x-intercepts are found by factoring your original function and then setting the numerator equal to 0. Well, on this one, the numerator can't be factored. We actually just factored the denominator to find the domain. We notice that by rewriting, none of the factors cancel. So at this point, we would set the numerator equal to 0. Well, the numerator is just 4. So if we set 4 equal to 0, you agree that that doesn't make sense. This is something that's not true. So in this case, if you get something that's not true, then you'll just say that there is no x-intercept. So I'm just going to say none. All right, let me go back up, and I'm going to use some room that I have over here. Next thing, third step, is to find the y-intercept. The y-intercept is found by evaluating your function at 0. Notice here that the function is called r, so I would say r of 0 equals 4 over 0 squared minus 81. So I would have 4 over negative 81. Now, in this case, it would be hard for me to graph 4 over negative 81, so just type that in your calculator and get a decimal approximation out. When you do that, that'll be approximately negative 0.05. So just a very, very small value. So we're going to put here that our y-intercept is approximately 0, negative 0.05. Alright, as our fourth step, I'm going to make a note of if I have any holes. Holes occur where you have factors that cancel. Well, in this case, we had things that factored, but no factors that cancel. So we will say none. Alright, from here, we now want to go and find asymptotes. So first of all, vertical asymptotes. Okay. To find vertical asymptotes, we want to set the denominator equal to 0 after we've factored and canceled. Well, we factored here, but nothing canceled. And so all we need to do is set the x plus 9 to 0 and the x minus 9 to 0. So setting x plus 9 to 0 would give me negative 9. And then setting the x minus 9 to 0 would give me positive 9. So the vertical asymptotes are x is negative 9 and x is 9. As my sixth step, I'm looking at horizontal asymptotes. Horizontal asymptotes depends on the powers of my function, numerator and denominator. Okay, notice here that the degree of the numerator is actually 0 because there are no x terms. Down here, the degree of the denominator is equal to 2. So in this case, the degree of the denominator is larger than the degree of the numerator. If that's the case, I'm going to go ahead and make that note. Degree of denominator was larger than degree of the numerator. If that's the case, then my horizontal asymptote is automatically y equals 0. So y equals 0 is my horizontal asymptote. All right, from here, step 7, looking for oblique asymptotes. Oblique asymptotes occur if we don't have a horizontal asymptote. In other words, the degree of the numerator is bigger than the degree of the denominator. Since we do have a horizontal asymptote, there will be no oblique asymptotes. So finally, we're to the graphing step. And so here, to graph, I want to go back up and I want to collect any kind of points that I had. Well, I didn't have any x-intercepts. The only point that I really have is a y-intercept. So I would go and I would plot that point. All right. On this one, before I worry about the units, just plotting the y-intercept, we know it's going to be very, 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 very close. It's that 0 and negative 0.05, so it's very, very, very close to your 0, 0, but from below. All right, now we also notice that we have vertical asymptotes at negative 9 and 9. Okay, so I'll go ahead and I'll mark those. I'm not going to actually mark the units, I'm just going to mark where it is. So let's say that this is negative 9 and this is positive 9. So I'm going to mark those as vertical asymptotes. Make sure that when you have vertical asymptotes, I'm going to say as far out as these are at 9 and negative 9, that you still have plenty of room on either side of them. All right. Now, this being the only point that I have, and these being the vertical asymptotes, I have almost enough information to tell what the graph would do. Looking back up, we had one more piece of information, and that was that we had a horizontal asymptote at y equals 0. So here, I'll go ahead and label that so I can see it, y 0. I should go ahead and also label these. All right, from down below where I have the y-intercept, I now have enough information to be able to graph this. I know here that my graph would be close to this horizontal asymptote and then eventually be pulled out towards the vertical. So this piece of the graph is going to look something like that, more or less. Now, in this situation, I know that I've got basically 1, 2, 3, 4, 5 other regions that my other pieces of my graph could be in. There's only one of those regions that I know it couldn't be in. And the one region that I know it couldn't be in would be the region up in here, because in this case you'd have to have another y-intercept, and then also it would cause my graph not to be a function. So I know that's the only piece that I couldn't be in. Now, to figure out which of the other pieces that I'm in, I really would need to use a graphing calculator. So let's go to the calculator. The first thing I want to make a note of is if you are graphing using your graphing calculator, make sure that whatever you enter into y1 has parentheses around the top and the bottom. So let's say here if we're going to plug our original function into y1, we need to make sure to put the 4 in parentheses and the x squared minus 81 into parentheses. So 4 divide by, and then x raised to the second minus 81. All right, we're going to try this in a standard window. I don't really think a standard window is going to work because my vertical asymptotes are very close to that negative 10 and 10. But let's try that to begin with, and then we can adjust it from there. Okay, I'm going to say here you can kind of see the piece of the graph that we have down here. On your calculator, you can't actually see this particular piece, and we're going to actually do something about that so that we can. We have a lot of y values up and down, so I'm going to actually adjust those and bring it further in, so maybe do 5 to negative 5. And then out here, I'm not able to see exactly what's happening on the ends, and so I'm going to make the x values a lot bigger and a lot smaller. So go to the window, let's do negative 20 to 20 on the x's. And then let's scooch the y's to be smaller numbers. So let's do -5 to 5. That may still not be small enough, but we can at least check and see. Graph that. Okay, and we can somewhat see now what our graph is going to look like. Let's see if we can do one more adjustment. Let's go to the window. Let's make the y's just a tiny bit smaller. Let's do -2 to 2. See if this helps any. Graph that. And that does help. At least now you can see this part coming up. That had to be very small because that y-intercept was very small. All right, now some of your calculators may have actual vertical lines where the vertical asymptotes were. Make sure that when you are checking on your graphing calculator, you know that those lines aren't part of your graph. You know that they are the dotted lines you have here. Now, all I needed to find out from my calculator is where these other pieces were, and I can now see that they would need to be in here and in here. So coming back to finish my graph, I would be pulled close here, have these little C-shaped pieces going towards my asymptotes. Same thing here, going towards the asymptotes.